This is the homework for October 12th. Numbers 1 through 6, the directions say to determine whether each equation is a linear equation. Today in class we said that there are really three things that we need to look for when determining if an equation is a linear equation. The first one is to see that if we have any exponents other than 1. So I'm just going to write exponents. We know that any linear equation can only have exponents of 1. The second thing that we need to look for is a variable in the denominator. I'm just going to write variable in denominator. And the third thing that we know about linear equations is that x and y can't be multiplied. So we're looking for those three things. If an equation meets these three criteria, then we know that it's going to be a linear equation. So we are just doing the odd numbers on this page, but you can do the even numbers as well for bonus points if you choose to do that. So on number 1, it says xy equals 6. Well, we know that x times y equals 6, and so since x and y are multiplied together, we know that number 1 is going to be non-linear. It's nonlinear again because x and y are multiplied. Looking at number 3, y equals 0. Well, are there any exponents other than 1? No. Are the variables in the denominator? Well, we don't have a fraction, so no. Number 3, are x and y multiplied? Well, there's not even an x in there, but we said today that that an equation that's linear can just have a single variable, and that's fine. So number 3 is going to be linear, and we'll look at how to graph that equation on Monday. Number 5, it says 4x equals 2y. Well, are there any exponents that other than 1? No. Are there any variables in the denominator? No. Are x and y multiplied? No. So number 5 is also going to be linear. Number 7, 8, and 9, the directions say which of the ordered pairs given are solutions of the equation. So on this, we've talked about today that with linear equations, we can really have more than one solution to an equation. We can have an infinite number of solutions to an equation that is linear. So that's what we're going to be looking at on this. The equation is 3x equals 2y minus 1. We know that if a solution, that any solution to an equation makes the equation true when we substitute these x and y values in place of x and y. So we have the ordered pair 1, negative 2. So if we take out 3, or if we take out the x and put in the value of x, which is 1, we get 3 times 1 equals 2 times y. Well, we're saying that y is negative 2 minus 1. Well, we're looking for the left side to equal the right side. If they do, then we know that the solution is or the ordered pair is a solution to the equation. So 3 times 1 is 3. On the right hand side, 2 times negative 2 is negative 4. Negative 4 minus 1, when we simplify that, we get negative 5. Well, is 3 equal to negative 5? It's not. So A is not a solution. Well, let's do the same thing with B. We'll do 3x equals 2y minus 1, and we know that we are going to use negative 1 for x. So 3 times negative 1 equals 2 times negative 1 minus 1. Again, I just took out the x and the y and put in the value of x and y, our x coordinate and our y coordinate. When we simplify the left hand side, we get negative 3. On the right hand side, we get negative 2 when we multiply, minus 1. When you subtract, we get negative 3 on the right, and we had negative 3 on the left. So that tells us then that B is a solution. Okay, but in the instructions, which of the ordered pairs given are solutions of the equation? So we said today that this S tells us a lot. That means that there could be more than one solution. So we need to check options C and D as well. On C, we're going to do 3x equals 2y minus 1, and we know that the x value is negative 2. So 3 times negative 2 equals 2 times negative 5 halves minus 1. When we simplify the left-hand side, we get negative 6. When we simplify the right-hand side, we get negative 5. When we multiply, minus 1 would be negative 6. So negative 6 equals negative 6. The left-hand side equals the right-hand side. So we know that that is a solution. So I'm going to circle C because we know that C is a solution also. And then D, well, D is the point 0, 1/2. We're going to take the equation on number 7, 3x equals 2y minus 1, and take 0 and put it in place of x, so 3 times 0, and then take negative 1/2 and put it in place of 2, so 2 times negative 1/2 minus 1, and we want to see if the left-hand side equals the right-hand side. Well, on the left-hand side we get 0. On the right-hand side we get negative 1 when we multiply. Minus 1 gives us negative 2. Is 0 equal to negative 2? No, that means that D is not a solution. So on number 7, our answer should be B and C. Looking at number 9, on number 9 we would do the same thing. We're going to plug in our x coordinate and our y coordinate for A and B. In this case, the first letter would be A. Instead of x and y on this problem, our variables are A and B, so we would do that this is A and this is B. This is A and this is B. So plug in each of those like we did on 7 and see which of those answer choices, again we might have more than one, make the equation true, make the left-hand side equal to the right-hand side. One of the big things that we've said we need to be able to do with this chapter and really for the rest of the school year is to be able to solve for an indicated variable, especially y. On numbers 10 through 13, the directions say that we're solving each equation for y. That means we want to get y by itself in the equation. Right now, y has been multiplied by 3, and then 2x has been added to it. So our first step would be to subtract 2x from the left and the right. The 2x's would cancel. And once we've done that, we end up with 3y on the left-hand side. On the right-hand side, we can't subtract 6 minus 2x and get 4x. These are not like terms. A lot of people are still making this mistake when they're taking tests. These are not like terms, meaning we can't subtract them. So the only way we can express that is 6 minus 2x, or I'm going to write it as negative 2x plus 6. The reason that I want for you to get used to seeing it like negative 2x plus 6 instead of 6 minus 2x is that in the coming weeks we are going to be talking about some different forms of linear equations, and one of the big ones that we're going to be talking about looks like this: y equals mx plus b, which is slope-intercept form, where we have the x in front and then the number that goes along with x that's added or subtracted from it coming to the right. At this point, we're one step away from getting y by itself. We need to divide the left by 3 and divide each part on the right by 3. When we do that, the 3's cancel on the left, giving us just y on the left-hand side. On the right-hand side, well, negative 2x over 3, we can simplify that. If we want to put it in this form, we would bring the coefficient out in front. So instead of negative 2x divided by 3, I'm going to write that as negative 2/3 x. And then 6 divided by 3 is 2, so plus 2. Since it's positive 2, we'll write that as plus 2. Again, that was number 10, which is one that you didn't necessarily have to do. So we'll do 14, or number 13 as well. So again, the ones that are required are the odd numbers, so 11 and 13 from this section. On 13, we want to get y by itself, so I'll subtract the 1/4 x from the left and subtract the 1/4 x from the right. The 1/4 x's cancel, so on the left-hand side, all that we're left with is negative 5/8 y. And then on the right, we have 1 minus 1/4 x, or I'm going to write that as negative 1/4 x plus 1. At that point, to get y by itself, we need to divide the left by negative 5/8, and we're going to divide each part on the right by negative 5/8. When we've done that, the negative 5/8 divided by itself on the left cancels, which just gives us y on the left-hand side. On the right-hand side, if we divide negative 1/4 by negative 5/8, we're going to get 8 over 20 x. And then if we divide 1 by negative 5/8, we're going to get negative 8/5, so minus 8/5. Well, we can simplify part of this. The 8 over 20 can simplify to 2/5, so 2/5 x minus 8/5. At that point, we have y by itself. All of the terms on the right-hand side are in simplest form, so we know that we've solved that equation correctly for y. On the next section, the directions say solve each equation for the indicated variable. So we're doing the same thing as we did on the last section, numbers 10 through 13. but it specifies which variable we're solving for. So it might be x, it might be y, it might be a or s. Okay, so we are still just doing the odd numbers on this section. So let's look at number 15. On number 15 we have 5x equals 20 minus 10y, and it says we're solving it for y. Well, if I want to get y by itself, y has been multiplied by 10 and that has been subtracted from 20. So I want to get rid of the 20 first. So I'm going to subtract 20 to make that equal 0. Again, don't be tempted to add 20 since you see the minus sign. We want to get 20 to 0, so we need to subtract 20 from the left and the right. The 20s cancel. So on the left hand side we have 5x minus 20. Well, I can't subtract those and get negative 15x. These aren't like terms. Again, they don't have the same variables and exponents. So the only way that we can express that is just 5x minus 20. On the right hand side, at this point we have negative 10y. Now we're one step away from getting y by itself. We need to divide the left by 10, and we're going to divide each part of the right by negative 10 as well. When we do that, the negative 10s on the right hand side cancel, so all that we're left with at that point is just y. On the left hand side, if we simplify each of these, well, 5 over negative 10, that's the same thing as negative 1/2, and I'm going to bring the fraction out in front. Negative 1/2 x, and then negative 20 divided by negative 10 is positive 2, so plus 2. So negative 1/2 x plus 2 equals y. At that point, y is by itself, so we know that we have successfully solved that equation for y. Let's look at number 17. On number 17, the directions are the same, but what we're doing is solving that equation for x. So in this case, x has been multiplied by 6, 3y has been added to it, and it's equal to 6. So our first step is to get rid of the term that is being added to the term with the x. So minus 3y from the left and the right. At that point, the 3y's cancel, and what we're left with on the left-hand side of the equation is just 6x. On the right-hand side of the equation, these are not like terms, meaning that we can't subtract those. The only way that we can express that is we can write 6 minus 3y, or I'm going to write that as negative 3y plus 6. The variable term is going to come in front. At that point, we're one step away from getting x by itself. At this point, though, x has been multiplied by 6, so we need to divide the left by 6, and I'm going to divide each part of the right by 6. The 6 divided by 6 on the left cancels, just giving us x. On the right hand side, the negative 3 over 6 reduces to negative 1/2, and I'm just going to bring the negative 1/2 out in front, so negative 1/2 y. The 6 divided by 6 is 1, so plus 1. At that point, the x is by itself, which means that we have successfully solved that equation for x. Numbers 19 and 20, be sure that you do those as well. And again, all of the even numbers on this homework assignment are for bonus points if you do that for Monday. And then the next thing that we were going to look at is on the back side of the sheet. This is where we're actually graphing linear equations. We gave a 4-step process for graphing linear equations today. And the first one, the first step that we needed to take was the same thing that we did on this last problem. We need to isolate the y. We want to solve this equation for y. So on 23 we have x minus y equals 5. Well, let's get y by itself. To do that, I can subtract x from the left and subtract x from the right. When we do that, the x's cancel on the left, giving us negative y on the left. On the right, we have negative x plus 5, so I'll write that, or x minus 5, but I want to write it as negative x plus 5. Put the x in front. At that point, we almost have y by itself, but this is negative 1y, so we'll divide the left by negative 1 and divide each part on the right by negative 1. Well, the negative 1 divided by itself is going to cancel. So on the left-hand side, all we get is y. On the right-hand side, negative x divided by negative 1, that's just going to be positive x. 5 divided by negative 1 is negative 5, so x minus 5. At this point, for number 23, we have solved that equation for y. The second step we said in class that we needed to do was to make a table of values to get some solutions for that equation. So it tells us in the instructions, use the domain negative 1, 0, 1, and 2. We said the domain means all of the x values that we're going to use. So over here in this table of values, I'm just going to fill in negative 1, 0, 1, and 2. Again, we can use this domain. In this case, we need to because that's what it tells us to use. But if it doesn't specify what to use, we can use any numbers that we want. I just recommend using small numbers and numbers that are going to give you whole number answers in our equation. So we'll see some in a minute where we'll pick and choose a little bit differently what numbers we use if you're given the option. If it tells you to use this domain, though, then we need to use that domain. Once we've filled in our x values in our table of values, now we need to figure out what the y values are going to be when we use those x values. Well, we know that we want to use -1 for x, so if we want to know what y is when x is -1, then we'll write -1 minus 5. Well, -1 minus 5 is -6. So when x is -1, y equals -6. Let's do the same thing for 0. Well, instead of x minus 5, we'll do 0 minus 5. 0 minus 5 is -5. So when x is 0, y is -5. Let's do the same thing with 1. Instead of x minus 5, now we'll do 1 minus 5. 1 minus 5 is -4. And then finally, 2. If we put in 2 for x, instead of x minus 5, we have 2 minus 5. Well, 2 minus 5 is -3. So at this point, we have 4 ordered pairs that are solutions to this equation. That means that if we stuck in -1 for x and -6 for y, it made the equation true. Same for the other 3 ordered pairs that we got. The third step we said in graphing a linear equation is to plot those points on the number line. So -1, 6 would be located here. 0, -5. 0, -5 would be here. 1, -4 would be here, and 2, -3 would be here. If we've done this correctly, knowing that this equation that we started with is a linear equation, our points should form a straight line. If they don't, then we know that we messed up somewhere. Okay, and then our fourth step is to draw a line through the points. And again, we do want to put arrows on both ends because we want to make sure that we understand that that graph shows all of the possible, represents all of the possible solutions of that equation. So don't just connect it from one end or one dot to the last dot. We want to draw a line all the way through across the graph with arrows on both ends showing that those points are all the ordered pairs that touch that line are solutions to that equation. And then we'll look at one more. Let's look at number 25, and that'll be the last one that we look at. Actually, let's look at number 29 so that we can handle those fractions. All right, so looking at 29, our first step we said is that we want to solve the equation for y. Well, we're starting off on that problem with 1/2 x plus 3/4 y equals 1. We want to get y by itself. So my first step is going to be to subtract 1/2 x from the left and subtract 1/2 x from the right. The 1/2 x's cancel and we end up with 3/4 y on the left. On the right hand side we have 1 minus 1/2 x, or negative 1/2 x plus 1 is how I'm going to express that. At this point, let's divide both sides by 3/4 to get rid of the 3/4. We're going to do that to both sides. The 3/4 cancels on the left, leaving us with just y on the left hand side. On the right hand side, if we divide 1 by 3/4, we get 4/3. And if we divide the 1/2 by 3/4, we're going to end up with negative 2/3. So negative 2/3 x plus 4/3. All right, at that point, y is by itself, so we're going to substitute in some values. In the instructions, it tells us to use the domain -1, 0, 1, and 2. So that is what I want to use, -1, 0, 1, and 2. And if it didn't tell us in the instructions what numbers to use for the domain, then I would just use any that I wanted. Okay, I'm going to substitute in -1 for x, so negative 2/3 times 1 plus 4/3. Well, negative 2/3 times 1 is negative 2/3. So negative 2/3 plus 4/3. If we add that, we get 2/3, which if we change 2/3 to a decimal, I've messed up somewhere. Yeah, this should be a negative 1. So negative 2/3 times negative 1 would be positive 2/3. 2/3 plus 4/3, that's going to give us 6/3, which is just 2. So when we substitute negative 1 in, we get the whole number 2 for y. Then if we do the same thing with 0, instead of 2/3 times negative 1, we'll do negative 2/3 times 0 plus 4/3. Well, negative 2/3 times 0 gives us 0, so 0 plus 4/3, that's just going to be 1.3 repeating when we add that. So I'm just going to write that as 1.3. And when we plot these points, it'll be an estimate now that we see that we have a decimal as our y value. Then we'll do the same thing with positive 1. Negative 2/3 times 1 plus 4/3. Negative 2/3 times 1 is negative 2/3. Negative 2/3 plus 4/3. When we add those, we get positive 2/3, which if we wrote as a decimal would be 0.6 repeating. So when x is 1, we know that our y is going to be 0.6 repeating. And then finally, we need to substitute in our last x value, which is 2. So we're going to take out the 1 and make it negative 2/3 times 2. Negative 2/3 times 2 is going to give us negative 4/3. Negative 4/3 plus 4/3, when we add those, we get 0. So when x is 2, y is going to give us 0. So once we've gotten these 4 points, then we need to plot those on the coordinate plane. Negative 1, 2 is going to go here. 0, 1.3, we need to estimate. It's about a third of the way between 1 and 2. Is going to go somewhere in there. 1 and then 0.6 repeating is going to go somewhere in there, and then 2, 0 would be here. So once we've gotten those 4 points plotted, the final step is to draw a line that goes through those 4 points. The reason that we use 3 or 4 points is to make sure that those dots form a straight line. If we only have 2 points, then we can't be certain that those points are forming or that we didn't mess up and get a point in the wrong place. But if we get 3 points and one of them doesn't line up, then we know that we've messed up. Hope this helps.